Okay, again, okay, so could you give me a minute please? Thank you. I have to hydrate myself. Yeah. Fine. So again, in this question we are given a value of VDD. VDD is equal to 10 volts. RL is equal to 50 kilo ohms. Okay. VDD is equal to 10 volt. RL is equal to 50 kilo ohm. Mu and Cox is given. VTH is also given. All those things are given to you. Now, if VB is equal to 5 volts, that is the first question. Then tell me what is going to be the find the small signal parameter of the circuit. So you probably need one more information here. W by R also you have to assume something. No. So here one more information is missing. Assume bias at edge of saturation. Okay. Fine. Yeah, so tell me, how do you target this question? If VB is equal to 5 volt and all the other information is given, find the small signal parameters of the circuit, also find out the small signal gain. Assume bias at the edge of saturation. How do you solve this? So come to this. This is question number 1, this is 2, this is 3. Yes. Fine. So let's solve question number 1. Solution number 1. Okay. The first information that we should use is it is biased at the edge of saturation. Okay, that is the first information that we should use now here. So at the edge of saturation, let's call this VD only. Okay, so tell me what is VD? VDS is going to be how much at the edge of saturation? What is VD? Rather VDS is equal to how much? VGS
4 volts.
minus VTS. Yeah, correct. 4 volts exactly. It's going to be 4 volts because VTH is equal to 1 volts. Yes. So VDS we know, fine. Now if we know VDS, we also know this VD and RS. So I know the current, right? So what is going to be the current ID? Current ID is going to be VDD minus VDS upon RL. How much is that? VD is equal to 10 volts, right? 10 volt minus VDS is equal to 4 volts upon RL is how much? 50 kilo ohms. So 6 by 50. That's not a very good number. So assume it is 60. Fine. So it is 6 upon 60 kilo ohms. How much will that be? So this will be 0.1 milliamperes, right? Correct? ID we know. How much current is going to flow through this? That is something which we know now. Okay? Now I want to find out what are the small I want to find out the small signal parameters of the circuit, right? Of this MOSFET. So how do you find out the small signal parameters of a MOSFET? What are the small signal parameters of a MOSFET? Could you please remind me?
Transconductance.
Yeah, one second. So small signal parameters of a MOSFET. It is one is transconductance. Very good. Denoted by GM. Okay, or you can say it is Y21. Fine. What else? Yeah, what else?
Resistance.
What resistance? What resistance? Output resistance, right? R out, or you can also call it Y22, right? Isn't it? These are the small signal parameters, right? Of a MOSFET. We know that for a MOSFET, Y11 is equal to 0, right? And Y12 is also equal to 0 for a MOSFET. We know that, correct? Fine. So what is transconductance Y21 or GM? What is that value? Correct? So what is that? What will that be? This is also equal to how much? Isn't it? Am I right?
Yes.
Yeah. So which one do you think should we use right now? And we can use any of these, right? Either this or this, because we have all the information known to us. So let's use the second one. ID 2 ID by this thing. So GM is equal to 2 into ID is how much? 0.1 milliampere, right? Upon VGS minus VTH. What is VGS minus VTH equal to? 4 volts. So how much is this? 0.5 into 0.1 milli. 0.05 millisiemens or 50 microsiemens. Correct? Am I right? Yeah. So this is the GM value. Now what is the output resistance? What is the output resistance here? What is the output resistance here? It is nothing, right? It is 0. I mean, sorry, I made a mistake here. 1 over y22. It's 1 over y22. So we know that in this case y22 equal to 0. So R out should be how much? Infinity. Isn't it? So these are the small signal parameters. Am I audible now?
Yes, sir.
Yeah, my camera suddenly turned off. Fine. So R out is equal to infinity. So these are the small signal parameters, right? Now tell me how do you find out the small signal gain? That is also something which we need to find out. We also need to find out the small signal gain of the circuit. So the circuit is this one. We have the following circuit. VDD. This is RL. This is the MOSFET here. VB, VI is ground. This is VD. So what is the small signal equivalent of this? Or rather incremental equivalent? What is the incremental equivalent of this? How do you draw the incremental picture of this particular case circuit? How do you draw it? We learnt it, right? VB has to be shorted, right? All the independent DC voltage sources you have to short, correct? All the independent DC voltages you have to short. So where are the DC voltages here? This is one, this is another one, right? These two you have to short. Fine. And also you have to replace this MOSFET with its incremental picture. Got it? So let's try it once. This VB I have to short, right? So VB shorted here. VI I cannot short because that is a small signal only. All right. MOSFET I have to before MOSFET, before we touch MOSFET, let's replace it with a box here. Let's replace it with a box and say that it has parameters y11, y12, sorry, y21, y12, y22. Okay, and this is, let's say, ground, and the other terminal is here, right? This is the other terminal. So here VDD I have to short to ground, right? So at this point I have RL. This is, let's say, the output of this guy here. Let's say this is the input, this is the output here. This is VD. So here it will be replaced like this, VD, and then you have RL. Okay. Yeah. So now replace this guy, this box, with the actual incremental picture. So how will that be? This is VI. At the gate, what will I do? At the gate, I will simply put a gate sign here, right? Plus, minus, let's call this some VGS. Okay, small VGS. This is too small. VGS. And at the drain side, I have a voltage control current source, correct? Then we have this 1 over y22, right? And then we have RL, and this is our drain, right? This is our source. This is source. This is source. So this is VD, VI. Is this understood? Is this understood?
Yes, sir.
Yeah, good.
Yes,
This
sir.
is GM times VGS. Okay, fine. So this is not visible. Okay, now it is visible. Fine. So now tell me, we know what all things we know. GM we know, we have already found out here. GM for 50 microsiemens, right? We also know Y22, right? Y22 is 0. So 1 over Y22 is how much? Infinity, isn't it? So this is infinity. We know that. So any resistance which is infinity is as good as saying that it is open, right? It is open, correct? There is no resistance. I mean, there is infinite resistance, which means there is no connection. It is open, effectively open. Fine. So if we try to simplify our figure here, it will be what kind of figure now? I have Vi here. I have the gate here. Rather, let me just copy and paste it. It will be much more simpler. Copy, paste. Okay. Just remove this from here. Yeah. Now tell me what will be the incremental gain. So incremental gain is what? Vd upon Vi, right? So how much will that be? How much will that be? Minus Gm times RL, right? This is going to be the incremental gain, isn't it? So how do I found it out? How did I find out what is the incremental gain? Because of this Vi, I want to find out a relationship between Vd and Vi. So incremental gain is Vd upon Vi. This is the incremental gain. So how do I find it out? So because of this Vi, what is going to be the current here? This current is going to be, or small id only. This is going to be how much? Small id here is going to be V
GM
upon
into
Vi, right?
VI.
Correct. And what? So because of that, this current, where is this current going to flow? In this direction, right? So what is Vd in that case? Minus id times RL, which is equal to minus Gm times Vi times RL. So Vd equal to minus Gm times RL times Vi. Hence Vd upon Vi is equal to minus Gm times RL. Got it? So this is the small signal gain. So what is the in terms of values? What will be the value here? 50 microsiemens, right? Into RL was how much? 60k, right? 60 into 10 to the power 3, right? So 3 and minus 6 becomes minus 3, right? 5 into 6 is 30, so this is minus 3. The gain is minus 3, isn't it? The gain is minus 3. By the way, do you guys know what is the meaning of this minus sign here? Gain is minus. So what does that mean? Incremental gain is minus. So what does that mean? Minus sign here. What is the meaning of this minus sign?
I think it is just the polarity of the VD.
So you mean to say that VD will be negative here. In this case, VD will be negative here. But we already saw that VD cannot be negative, right? It has to be in saturation. So VDS is equal to 4 volt. It is given. So what is the meaning of this negative sign here?
In power, we have an idea that we can deliver. If when it is negative, we are delivering. In voltage,
No,
we
no,
say
no. It's not that. Okay. I mean, it might become that, but here the meaning of saying that VD over VI is minus 3, it means what? It means that this, please note that this is an incremental picture, okay? This is not the this is not the bias point picture. This is incremental picture. So what it simply means is that if you have a small change, small incremental change here, okay, at the gate, let's say you increase Vi slightly, okay, you increase it the Vi slightly here, okay, what is going to happen at this node is that this is going to decrease slightly. That is all. That's all is the meaning of this. Okay, meaning of -3 is that the gain is negative, which means what? If something is increasing in response to that, gain negative means in response to that something else is decreasing. Input increasing, the output is decreasing. That is the meaning of negative gain. Okay. So it means here is that if you increase Vi by 1 millivolt here, okay, then at the output Vd will decrease by 3 millivolts. That is the meaning of this. Understood? Is that point understood?
Yes.
Yes, yes.
Yeah. The meaning of negative gain is simply that the sense of swing is opposite. Okay. If the yeah, that is the meaning of this. That if the sinusoid is moving in this direction like this here, in the at the output, the sinusoid is going to be in this direction. Got it? That is the meaning of negative gain. Good. So this point is understood. Yeah. Now here we have assumed Vb is equal to 5 volt, right? And because of that, and we also assume that it is Vb is equal to 5 volt and it is at the edge of saturation. So we said that we found out that the gain was how much? Gain was equal to -3. Let's say we are not happy with this gain, okay? We say that the gain is not enough, we want to increase the gain, because that is overall the point of power gain, right? We want to increase the amplification to how much ever it is possible, right? So we want to increase the amplification. So let's say I want to get a gain of -100 from the circuit. Now you will be able to appreciate the fact that what is meant by minus, right? Now you are able to understand why is the sign minus here. Okay, so now let's say I want to increase the gain to -100. But for that I am given a handle. What is the handle here? I can increase or decrease Vb. Okay. So the question is, what should Vb be for a small signal gain of -100? What should Vb be for a small signal gain of -100? Again, we are assuming that the transistor is biased at the edge of saturation. Okay. That is the assumption here. Tell me, how do I target this question?
So you can use the GM formula to do that.
Okay, let's try that. So this is the situation here. Yeah. So uh, yeah, we want to have a gain of -100, correct? To have a gain of -100, find Vb for this gain. So you said that we can do the use the formula of What should I do? First tell me what should be the first step. What should be the first step of that I should do here? First of all, I know that what is required from me. I require the gain, right? So the first information is that the gain is given to me. So that gain is equal to how much? I already saw, right? Gain, incremental gain in this kind of a circuit is how much? Minus GM times RL, right? So minus GM times RL has to be equal to minus 100. So from there I know what is GM going to be, because RL I know already, right? RL is equal to how much? 60k, correct? So GM is equal to 100 upon 60k. So how much will that be? 10 upon 6 millisiemens, right? That's a weird number. So let's assume something else. Let's make it not 100 but 60. Okay. So that calculation is easier. Let's make the calculation easier. Yeah. So in that case it becomes 1 millisiemens, right? So I need how much GM? The GM should be equal to 1 millisiemens, correct? For me to achieve a gain of minus 60 here, I need a GM of 1 millisiemens, correct? And from the earlier analysis, I know what is GM equal to. As one of you already said, GM, we can use this formula, right? We can use this formula. So this one or this one, which one should I use out of the two? Tell me, should I use this formula? Should I use this one or this one? Which one should I use for calculating GM here?
2 ID by VGS minus VDH.
And why do you say that?
We don't have W by L values.
Yes, exactly. We do not know what is this W by L, right? So we cannot go ahead and use that. We should use this guy because this we know, right? Yes. So GM is equal to how much? 2ID upon VGS minus VTH. And okay, yeah, we also do not know what is ID, right? How do I find out what is ID? So if you look carefully here, I have already given here. Assume that the transistor is biased at the edge of saturation and triode region, which means what? I know what is the value of VDS, right? I know what is VDS. What is VDS?
Four volt, I think.
No, that was when VB was known, right? I have to find out what is the VB here, right? The question itself is that what should the VB be? It's not the
Oh,
4 volt anymore, right? So at the edge of saturation, VDS is equal to VB minus VTH. Okay, this much is known to us. Let's use this. So ID is equal to VDD minus VDS upon RL, that is equal to VDD minus, and VD is known, right? VB minus VTH upon RL. So what will this be? VDD minus VTH upon RL minus VB. So this is VDD plus VTH, V by RL. Correct. So what is VDD? 10 volts, right? VDD was 10 volt. So this is 10, 11 volt divided by RL is how much? 60k, right? 60k minus VB upon 60k. So this is my ID.